Okay, next up we want to figure out how to convert between polar and rectangular coordinates. Let's just write down what that means. Rectangular is Cartesian, so you're using x, y, z coordinates. And with polar, instead you're using some radial coordinates and some angular coordinate. And so polar would typically be best in like scenarios where you're looking or you're dealing with circles that have a certain radius. And so now let's write out what each of these coordinate systems are. With the rectangular system, if I have a point here, I would identify it using its x coordinate, so how far on the x-axis I have to travel. So if I have whatever point, I travel on the x-axis and I travel on the y-axis to reach my point. Apologies. To reach my point, oh god, up here. And so if I identify the point in red, I would say that that point is located at whatever distance it traveled on the x-axis and whatever distance it traveled on the y-axis. So I'd identify it with x, y, if we're working in 2D. Now with my polar coordinates, instead of doing that, and identifying it with those two pieces of information, instead, if I have my point located at this point in space, I will travel along the line directly to it, so the shortest distance to it, and we'll call that r, and I'll just take a note of what angle I'm making with the x-axis, so theta. And so those are the two coordinates that you're using. And so if I want to be able to find, basically convert between polar and rectangular coordinates, so if I wanted to find r from this, I can see quite clearly that r is going to be just here. And so using our right angle Pythagoras theorem, I know that r will be equal to x squared plus y squared, and that theta I can find by doing the inverse tan of y over x, and that's simply on SOHCAHTOA, so tan of this angle is opposite over adjacent, y over x, and then I simply solve for theta using inverse trig. Okay, so this is how I'd get polar coordinates from rectangular coordinates. Now I need to figure out how I can get rectangular coordinates from polar coordinates. And so again, just apply Pythagoras and draw out your right angle triangle. And from this, I can see that x, y, if I use SOHCAHTOA, that means that sine of theta would be opposite over the hypotenuse, so that would be y over r, and that cos of theta would be adjacent over the hypotenuse, and so that's going to be x over r. And so if I wanted to solve for x and y here, and I only have polar coordinates here and here, so also in the equation, then I can be able to do so. So y is going to be r sine theta, and x is going to be r cos theta. And so this is how you convert from polar coordinates to rectangular coordinates, and this is rectangular coordinates to polar coordinates. And that's it for this question.